And finally, we're integrating tangent and secant. To integrate higher powers of tangent and secant, we need to use the identities tangent squared equals secant squared minus 1 and secant squared equals tangent squared plus 1. And then we integrate by parts when necessary to reduce higher powers. So for example, when I have tangent to the fourth of x, I'm going to go ahead and change that into a tangent squared times tangent squared. I'm going to take one of those tangent squareds and change it into secant squared minus 1. This way I can do a u substitution. So let's go ahead and distribute this. For this first one, this is where we can do our u substitution, because if we let u be tangent x, then I know that the derivative of u is secant squared x dx. So it covers this up very nicely into u squared du, which you can then integrate. And the tangent squared x, of course, I can change into secant squared x minus 1, which then makes a nice, easy integration, because the integral of secant squared is tangent, and the integral of 1 is x, and this minus sign goes to both of those. So now I can go ahead and finish this first one. This is going to become tangent to the third x over 3, because of course it becomes u cubed over 3. And pretty much now I have my answer. Tangent cubed x over 3 minus tangent x plus x plus c. For this next problem, I'm going to do a similar tactic. I'm going to split up secant cubed into secant times secant squared. That allows me to now do integration by parts, because I know the integral of secant squared. That's going to become my dv. Integral of secant squared is tangent. That makes u the secant x, and du would be secant x tangent x. So now I can use integration by parts and do u times v minus the integral of v du. Now notice the du's got a tangent in it, so I'm just going to do tangent times tangent is tangent squared. And I'm going to go ahead and over here make my tangent squared into secant squared minus 1. That allows me to distribute the secant right here. And then I notice, this is suspicious. I ended up back in the same place that I started. Oh, no, that's terrible. What on earth shall we do? So we started with secant cubed. And I ended up with secant x tangent x. Hey, that's fine. I ended up with a minus secant cubed. Hey, wait a minute, that's where I started. And I have a minus, oops, actually it is a plus integral of secant. So what I'm going to do is, a la peanut butter sandwiches, we're going to add this to both sides of the equation, which makes 2 of them. And remember we said that we should add the integral of secant to our list of things to know. Do you remember we said that that was ln, absolute value of secant x plus tangent x? You should make sure you have that in your memory. And now I can go ahead and divide everything by 2. So I get the integral of secant cubed x dx equals 1/2 secant x tangent x plus 1/2 ln secant x plus tangent x plus c. And finally, we have this lovely problem right here. Let's go ahead and fix this one. So what I'm going to do is take my secant to the 4th and change it into secant squared times secant squared. And again, I did that because my forward thinking knows that if I take derivative of a tangent, derivative of tangent is secant squared. So it will make a nice U substitution right there. So I can change this over into tangents. That is 1 plus tangent squared. But I'm going to leave this other secant squared for my U substitution. I end up with a tangent to the 4th x plus tangent to the 6th x when I go ahead and distribute. U substitution. du is secant squared x dx. Oh, how lovely. This makes a u to the 4th and a u to the 6th, and this becomes du. And then I can go ahead and integrate. Voila! I will see you for extra help during the next class.